In the previous lesson, we used the Nernst equation to find the cell potential of this non-standard electrochemical cell, and that will depend on the Q. Okay, so what we want really is we want a lot of reactant, 5 molar, and a very little of the product. So according to the Le Chatelier's principle, to reach equilibrium, the reactants will turn into products. So that's our goal, to have a lot of reactant. Now we have something called a concentration cell, and that's what we will be covering today. Okay, in a concentration cell, they use concentration or molarity. Specifically, they use a lot of molarity in the reactants and very little in the products. But in the concentration cell, we have the same species. Okay, so for example, looking at this solution right here, this is nickel plus 2 in the solution, and this is also nickel plus 2. This solid is nickel solid, and this is also nickel solid. So as you can see, it's the same species. But if it's the same species and the concentration is the same, the voltage will be 0 because they have the same, the electrons will want it the same way, will be wanted the same way in both beakers. So what we can do is to change the concentration. Okay, so it's the same species, but you will get a voltage because you have different molarities. Okay, so let's analyze this a little bit more. So in this reaction, you have nickel, right? So here the electron's going to the right, which means nickel is giving away the 2 electrons, and it becomes nickel plus 2. Here you can see that nickel is oxidized. And this is also the anode, because oxidation occurs at the anode, vowels right here. That's how I remember it. Okay, so the nickel solid, this is solid, turns into nickel plus as nickel plus 2 as the solid becomes dissolved. Okay, so what they do here as the molarity of nickel plus 2, they made it really small to make the reaction proceed this way to the right, making the nickel plus 2. They make the molarity really small. Over here, what is accepting those electrons? 2 electrons specifically. That's correct. The nickel plus 2 is taking in the electrons. So the more you have of this, the better you're off. So they made this a lot higher in concentration. This is 1 molar, while this is 0.001. So that is, what, 1,000 times more on this nickel plus 2 to accept the electrons. So here, the nickel plus 2 is the reactant, is taking in 2 electrons as it becomes nickel solid. Okay, this is reduction, and this happens at the cathode. Okay, so for such a cell, for this cell right here, if you have 0.5 and 0.5 molar, your voltage is going to be 0 as shown here. Okay, but if you have this right here, it's called a concentration cell, your E naught will be 0, right? But Q is not going to be 0. Therefore, if you use the Nernst equation right here, even though this will be 0, you're going to get a value right here, and that's going to give you some voltage because Q is not going to be 0. Okay? As long as you have different molarities, the E of your concentration cell, not E naught, okay, will not be 0. Okay, let's do an example. Let's draw those cells again. You have nickel, okay? You have nickel plus 2. I'm sorry, you have nickel, or in the beginning you have nickel solid as it gives away 2 electrons to become nickel plus 2. This is being oxidized. So this is the anode. Okay, so this is the nickel plus 2 in the anode. I'm going to write AN there to distinguish it. Okay, over here, now the electrons are coming in. The nickel plus 2 is taking in the electrons, 2 electrons, to become nickel solid. This molarity is, this is a reduction because you're adding electrons into it, and this is the cathode. So this nickel is the cathode. Cat, C-A-T, cathode. So we have to write those subscripts to differentiate the two because they're both nickel plus 2. So I'm going to write the equations together. So the pink one is the anode, and the S becomes two electrons plus nickel plus 2, right? And again, I'm going to write anode right here. Okay, writing this one, the nickel plus 2. This is the cathode, takes in 2 electrons and becomes nickel solid. Okay, combining those two together, maybe I'll just use this color. You can see that this nickel solid cancels, the electrons cancel, and what you have is the nickel plus 2 in the cathode, arrow, nickel plus 2 in the anode. And that's what you're going to plug into Q. Now we're going to solve for E. So E, according to Nernst equation, E equals to E naught minus, don't have it memorized, should, minus 0.0592 volts and log Q. 0.0592 volts over N log of Q. Okay, so this is a concentration cell. They're both nickel. Oops. So the voltage, the E naught, will be 0. So this value right here is 0 minus 0.0592 volts over, and you transferred 2 electrons, as shown right here and right here. Okay, so 2 log of Q. I'm going to go ahead and solve for Q. Q is equal to products, nickel plus 2 in the anode over nickel plus 2 in the cathode. Okay, plugging it in. Nickel plus 2 in the anode. Looking at the picture here, this is the anode right here. The molarity is 0.001. If you don't mind, I'm going to write that as 0.001 molar. Okay, and this is 1 molar. Okay, so this is the anode. It's 0.001. So the anode is 0.001, and the cathode is 1.00. Okay, so that is Q is equal to 0.001. So I'm going to plug that into here. Okay, plug that in the calculator. You're going to get, let me just pause this. Okay, so when I calculated that, I got positive 0.0888. Okay, so numerically, you should be aware that if you have a lot of this, if this number is big, this is the reactant. If you have a lot of reactant, this value becomes a decimal, right? And if you take the logarithm of a decimal, you're going to get a negative number. This is actually -3. And if you have multiply a negative and a negative, you get a positive number, which makes this voltage spontaneous. So the key to concentration cells is having a lot of reactant. a lot of this reactant right here and very little product. This is the product right here to make the reaction proceed to the right. Okay. Solve for E when the concentrations are equal. If the concentrations are equal, you can see the following. E is equal to E naught minus 0.0592 volts over N log of Q, right? So if they were equal, you would have 0 minus 0.0592 volts over 2 log, let's say they're both 1 molar, 1 over 1. What is the log of 1? It is 0, which means you get 0 voltage. Okay. For sample exercise 20.13, you will do that yourself, and it's going to be just like what I'm about to do in the practice exercise. So they're very similar. I will do that on the next video.